Hello everyone, and welcome back to the part 2 lecture of our week 3 content. In this lecture video, we're going to discuss differences between independent variables and dependent variables, different types of independent variables, and we will also discuss the 6 criteria of good hypotheses. So once you've got a few potential explanations locked down for your research paper, it's time to make sure you understand which one is the dependent variable and which one is the independent variable. And we've been using these terms for about 2 weeks now, so you should start feeling a little bit more comfortable with the usage of these terms. So just for a quick recap, remember, the dependent variable is the measured phenomenon which we are trying to explain. When we start getting into equations for statistical modeling, the dependent variable is almost always referred to as y in a given equation. Our hypotheses will generally propose how other variables or explanatory factors affect the dependent variable, or the main variable of interest. And then lastly, the value of the dependent variable depends on the independent variable. So that's one easy way to remember which is which. With our independent variables, remember these are also our explanatory variables. They help us explain our dependent variable. Independent variables are often referred to as x in mathematical equations. And with our independent variables, we hypothesize that different values of an independent variable will have a specific impact on the dependent variable. So let's run through some examples and see how well you can identify the dependent variable and the primary independent variable in each of these following statements. So first, those who have acquired more formal education will have higher incomes. So let's start with the independent variable here. When reading through these type of questions, first ask yourself, what is causing a change? Okay, that's going to help you identify your independent variable. What is causing the change? So go ahead and pause the video for a moment. You can pause after I introduce each statement, and I want you to see if you can get it right. Which one is the independent variable and which one is the dependent variable? So when we read the phrase, those with more formal education will have higher incomes, we read that as education having an impact on income. So here, since education is causing something to change, education is the independent variable because it's causing a change on how much money we make. Okay? Feel like you got it now? Let's try another one. Students who study for at least 5 hours a week are more likely to make A's. So again, ask yourself, what is causing a change? Can you identify the independent variable causing change? So here, the amount of studying is assumed to impact the grades that we make. So study time is the independent variable, which is having an impact on the dependent variable, which is grades. So another way to think about this is that the grade that you make is dependent upon how much studying you do, right? So hopefully all of this is kind of coming together. Let's take another one. State House candidate Borman Norman won the most votes because he campaigned in rural areas more than his challenger, right? So there's a lot of terms going on here. What's going on? One thing to notice is that the word because is a dead giveaway because it signals that something happened because a specific factor caused something. So were you able to figure it out? In this statement, we are suggesting that the amount of time Borman Norman spent campaigning in rural areas, that had a direct impact on what? The number of votes he received. So here, I'll let you pause if you haven't figured it out yet, if you want the chance to try and get it yourself. The time spent campaigning is the independent variable, and that has a direct impact, or at least explains why he received more votes, the dependent variable. So I hope that thinking about these questions in terms of what is causing an impact or what is influencing a specific factor can help you determine the dependent variable and the independent variable in a given statement. I mean, usually it takes a little while to get familiar with these terms, and I've got a whole bunch of exercises planned on Thursday for us to keep practicing identifying variables in given statements. But I think it's just usually best to think about what in this statement is producing or causing a change. And that's always going to be your independent variable. So the thing that creates the impact is the independent variable, and the thing being affected is the dependent variable. Eventually, you'll get to the point where you're not even looking at the content of the statement, and instead, all you're doing is honing in on the language itself. So the final example states that when X increases, that it will also cause Y to increase. And since we can tell that X is having the impact, causing an impact on Y, we know that without it even being anything of substance, that X is the independent variable and that Y is our dependent variable. So I hope this exercise has been helpful, helping you get a little bit more accustomed with these terms. And like I said, again, if not, we'll do more exercises on Thursday. So hopefully now you feel a little bit more confident with knowing the difference between a dependent variable and an independent variable. So now I briefly want to focus on the different types of independent variables. Knowing the type of independent variable that you're working with is going to be really helpful later on when you're trying to develop hypotheses or explain relationships. How does the independent variable influence the dependent variable? Well, knowing exactly what type of independent variable it is, it can be immensely helpful. So there's essentially three main types of independent variables that I'd like you to know about. And that's 1, constants, 2, antecedents, and 3, intervening variables. Constants are super easy to remember. You can tell if a variable is a constant or not simply by looking at the values of each observation of a given variable. If the value for a variable does not change at all across any of your observations, then it's constant. It's unchanged. Antecedent variables contain a time component that's theoretically relevant to your question. Antecedent, which literally means to go before, means that these type of variables literally occur before any of your other independent variables, and I'll show you why that's important in just a moment. And then finally, we have intervening variables, which can be a little bit harder to understand at first, but intervening variables they help explain the dependent variable, obviously, but they are also affected by other independent variables. So before I go on any further, let's break for a quick example and figure out what the hell all of this actually means. Okay, so let's assume that we were interested in understanding why people voted for Barack Obama in 2008. So based upon the nature of the campaign and the political climate at the time, we know that universal health care was a huge policy agenda that Obama advocated for. So here we're identifying a potential relationship, an explanation between health care and voting for Obama. Let's say that we develop our first explanation or our first hypothesis. Perhaps people who favored universal health care will be more likely to vote for Obama in 2008. So now we have our independent variable, which is attitudes about universal health care, and our dependent variable, voting for Obama, or, vote choice broadly, in 2008. Who did you vote for in 2008? That's the thing we're trying to explain. So up until this point, I've been encouraging you just to think about variables that explain the dependent variable, the thing that you're really interested in studying. But you should also be thinking about how your independent variables might influence each other, and what kind of concepts can we measure to get at those relationships. And the more variables that you have in your data set that explain each other, the stronger your analysis will ultimately be. So think to yourself, what are some of the things that might influence our main independent variable of interest? What are some independent variables that might explain our other independent variable, attitudes about universal healthcare. So just keep in mind, the dependent variable, the main thing we're trying to measure, is why people voted for Obama. The rest of the exercise is all about coming up with those explanatory independent variables. So let's walk through the rest of the exercise. Well, certainly the quality of your current health insurance, that might be a major predictor of whether we support universal health care or not, right? I mean, if I am very satisfied with my health care coverage, I might not be interested or see a need for the government to create its own healthcare system. I don't need it. It's not important to me. On the other hand, if I am very dissatisfied with my current health insurance, or maybe I don't even have health insurance, I might be really, really supportive of the idea of the government stepping in and providing a more affordable option to me. So that's certainly one independent variable that also explains our primary independent variable. How much money I make could also be a good predictor of whether or not people are more likely to support universal health care. So people who are well off, they make a lot of money, their income is very high. We might not expect them to see a need for universal health care. They're very well off. What do they care? Conversely, someone living below the poverty line who can afford health care, well, they might want the government to step in and provide health care. Party identification should also play a huge role in helping us explain all of these variables, right? We know Democrats tend to support universal health care. We know that Republicans are sometimes more opposed to that idea. It's all about big government versus small government. So if I'm a Democrat, I might be more inclined to support universal health care. And if I'm a Republican, I might not like the idea so much. And also, this is a big time predictor of vote choice, right? We know that that partisanship is the biggest predictor of who you vote for in a presidential election. So this variable is really helpful. It helps us explain a lot, right? So altogether, all of these variables that we've just come up with should help us explain overall people's likelihood of voting for Barack Obama in 2008. So let's look at some fake data I threw together in Excel to get my point across. Imagine back in 2008, right before the election, that I conducted a short public opinion survey, and I interviewed 5 people, which is also a horrible sample size. It doesn't tell us anything, but it's just for the sake of the example. I interviewed 5 people, and I measured their responses on these key variables. So here, my unit of analysis is, I hope you can fill in the blank here, it is the individual person, and my dependent variable, which we've talked about pretty extensively, that is vote choice, right? So I asked each participant who they planned on voting for. That's my dependent variable, and I recorded their responses here. Okay, so here's the dependent variable. Next, I asked participants to tell me how they felt about universal health care. Remember, this is my primary independent variable of interest. I think that this is going to play a big role in explaining why people voted for Barack Obama or not. But I know that attitudes about healthcare aren't the only thing that matter when it comes to how people make their voting decisions. So I also ask a series of other questions that will help us understand exactly why someone voted the way that they did. So next I ask people whether they have a favorable or an unfavorable view of their current health coverage. Now I expect, or I hypothesize, that this will also have an impact on whether or not they support universal health care. Right? As well as whether they'll vote for Obama or not. And as we discussed on the previous slide, I also asked them to report their income and which party they identify with. So now let's apply these terms that we just learned, constants, antecedents, and intervening variables, to our fake little data set here. We already know that vote choice is our dependent variable, the thing we're trying to explain, and that all of these other variables, these are our independent variables. So let's see if we can figure out what type of variables they actually are. So first, are any of our independent variables a constant? Remember, a variable is constant when it has no variation and all of its values are exactly the same for all observations. So do you see a variable like that here? Again, go ahead and pause if you need to, if you want to look it over. Notice how our income variable does not vary at all across any of our respondents. In other words, the variable is constant. It does not change, right? And maybe we shouldn't have only surveyed college students in our sample here. Maybe we should have had a better measurement for income that wasn't broken up into such large brackets, since the variable doesn't vary. What this means is that we have no way of testing whether high or low levels of income produced any different results, because unfortunately, our variable doesn't vary. So it doesn't really tell us anything at all. How about antecedent variables? Do any of these independent variables occur before the other independent variables? Now, we can determine this by asking ourselves whether one might cause the other and see to what extent that makes sense. So we could just take these two variables, for instance. Would attitudes about universal health care, would that have an impact on which party we identify with? Well, probably not. We know that people generally develop their party identification very early in life, and very early in life. Okay. So it makes sense that party identification is antecedent because it occurs much earlier than these other variables. So party ID is a great example of an antecedent variable. It's something that most people develop very early in life, and likely it's going to come before all of your other variables. What about an intervening variable? Are any of these independent variables influenced by another independent variable? Well, yes, as we've already discussed, attitudes about our current health insurance coverage and our income probably has a big impact on whether or not we think the country needs universal health care. So we know that attitudes about universal health care is definitely an intervening variable because it's impacted by at least one other independent variable in our survey. Another really helpful exercise in determining how variables might influence each other and how they're all related is by drawing these arrow diagrams. And your book has a really great section on this, so just be sure to check out the weekly reading. I think it's chapter 4 that we're on this week, so definitely make sure to read the chapter there for a little bit more information. Again, arrow diagrams are going to be an activity that we do in class on Thursday, but basically what we do is we start by drawing a long arrow across the bottom of a page, and we put the dependent variable at the very end of that arrow. And now we want to document how each variable might influence one another. So we know that party ID is formed very early in life, so that's obviously one of our antecedent variables. Partisanship also probably explains our attitudes about universal health care and who we'll vote for, so we can draw lots of arrows there. We've already discussed how attitudes about current health coverage and income is antecedent to our attitudes about national health care or universal health care. And so after no time, we've already categorized our variables into very nice and neat arrow diagrams. They're actually quite messy, but all of this really helps us understand the theoretical process underlying our research question. And this is just really helpful because when you're writing your theory, your theory is just a really succinct statement that explains why you expect this phenomenon to work the way that it does. And your hypotheses test whether or not those explanations are true, okay? So there's really no limitation to how we might expect variables to influence each other. Let's say we wanted to examine how years of education, civic duty, and political knowledge might explain why people vote or not. So obviously we start our education at a very young age, so that variable is definitely antecedent, and our sense of civic duty is typically a learned behavior. It's likely influenced by how many years of schooling we have, so civic duty is intervening here. Sometimes we can even have multiple intervening variables. We might think that the amount of political knowledge you have will also make you more likely to vote, but political knowledge is also influenced by your years of education, right? So in this case, we have two intervening variables. Intervening variables can also be theorized to influence each other. I mean, literally, it doesn't stop. Like, the possibilities are endless. We know that countries with more oil wealth generally tend to be unstable. And we know that unstable countries generally witness civil war. We also know that oil wealth and instability cause ethnic fracture, and no doubt does ethnic fracture also lead to civil wars. So before you know it, after you begin your literature review and start seeing how interconnected all of these issues are, you've got arrows all over the place. This exercise of drawing arrow diagrams is really just to get you thinking about how all of your different explanations and your variables, how they're all related together. You're not going to have to do anything like this on the exam because that would certainly be rather messy, but we will keep doing exercises like this in the homework journal to get you more comfortable with the terminology of independent variable and dependent variable, and getting a better sense of how all of these different things, all these different things that we measure in the world, how they're all related to one another. So once we've mapped out our variables and identify them as antecedent or intervening, we can really start to understand the process of how all of our variables affect each other. And once we have an idea about the causal linkages, meaning what causes what between our variables, we can start to formulate our hypotheses. So again, if we wanted to understand the relationship between healthcare attitudes and votes for Obama, we would start with some of the more seminal works of political science that analyze why people vote the way that they do. The literature review will help us identify our theory, which will in turn lead to our hypotheses. So let's use the proximity model of voting that we discussed in the very first week of class. So what I have here on this slide is very much an example of how you might introduce your theory, how you would write about that in your actual research paper. So according to proximity models of voting behavior, and then you have a nice parenthetical citation here that lists the most seminal works in political science that have, written about proximity models of voting behavior, right? End parentheses. Voters are more likely to support candidates who take positions that are closer in ideological proximity to their own views. So remember in that exercise from week 1, we talked about, which candidate is a voter most likely to vote for. And I think the example was immigration policy. We're like, oh, well, a voter who supports amnesty, they're going to vote for the candidate who also supports amnesty, and not the one who's vocal of deportation, right? So very simple model of voting behavior here. And what we want to do is we want to apply this to our research paper talking about healthcare and Barack Obama in the 2008 presidential election. So the theory explains why something happens. And in this example, many scholars have shown that voters are more likely to support candidates that have the same or similar positions or issues. The hypothesis is a statement that tests the theory with empirical observations. So here we're testing whether voters who feel more favorable towards universal health care will also be more likely to vote for Obama, who advocated for universal health care. So this is a very good hypothesis because it meets the 6 criteria of testable hypotheses. Okay, for your research paper, your hypotheses must meet the 6 criteria. I'm going to walk you through each of these and give you examples of good hypotheses and bad hypotheses for each. First, it must be an empirical statement. So we've talked a lot about this. It must be observable. We must be able to verify the statement with data. Second, good hypotheses are stated in generalities. We'll talk about what that means in a moment. Third, it must be plausible. Right? Not fantastical. It has to be rooted in some type of logic. Fourth, it should be specific, not too narrow, not too broad, but just specific. Fifth, it should be stated in a way that corresponds with the analysis you intend to conduct. And finally, sixth, it must be testable. So let's walk through examples of good and bad hypotheses for each of these criteria. So first, we're starting with empirical statements. Are these things that we can measure? Are they verifiable? So the first hypothesis, democracy is the best form of government. Is that an empirical hypothesis? Well, I mean, the best form of government? I mean, this sounds kind of like rhetorical and absolutist. I don't really think this one's very empirical. Second, democracy is more likely in countries with high literacy rates. Okay, well, that sounds good. Still not sure how we'd measure democracy. We got to think about what terms we really want to use, but the primary independent variable here, high literacy rates, yeah, we can definitely measure that. I like this one. It sounds good. Third, people who live in democracies are happier than those who do not. That seems a little problematic. I'm not sure how we would get measures of happiness for people in every country. So feeling not too good about that one. And then fourth, democracies with full voter enfranchisement are the strongest. Well, again, these words, strongest, the best, again, those are kind of rhetorical. There's even like a sense of kind of normativity here. So I'm not really feeling hypothesis 1, 3, or 4. And hopefully you were able to pick out that hypothesis 2 was the strongest hypothesis here. Definitely empirical. We could decide on a conceptualization for democracy. So maybe we're just talking about, can people directly vote for their representatives in government? We can measure that, and we can absolutely measure literacy rates. So hypothesis 2, that's a good one. That's a keeper. Second, let's talk about generalizability. So people can get kind of hung up on this one a little bit. It's sometimes difficult when you're beginning the research process to make sure that it's not too narrow, it's not too generalizable. Let's start with we'll start with the narrow hypotheses and discuss why they're bad, and how the generalizable hypotheses improve upon the bad hypothesis. So hypothesis 1. Senator Stevens voted for a bill because it is the president's bill, and they are both Democrats. Well, I don't really care what Senator Stevens does. Is that telling me anything about legislative behavior? Can I apply what Senator Stevens does to any other politician or case? No, not really. That's way too narrow. So a better hypothesis that we could test, which would actually tell us more about the world, meaningful information, would be that senators are more likely to vote for bills sponsored by the president if they belong to the same political party. All right, that makes sense. We can test that, and we can see to what extent that's true. Second, the United States is a democracy because its population is affluent. Okay, if you say so. That doesn't really tell me much about the relationship between affluence and, governmental regimes. It just tells me that one thing is happening in one country. Why do we care about that? Instead, a better hypothesis would suggest that countries with high levels of affluence are more likely to be democracies. So that's great. So we could really analyze the relationship between how affluent a population is and whether or not that's correlated in any way with the political regime. Third, the United States has more murders than other countries because so many people are gun owners. Okay, again, these are all pretty narrow because they're only referring to one specific case. That's generally going to be the problem with all of these type of hypotheses. So a better hypothesis would be that countries with more guns per capita are more likely to suffer more murders, right? We can easily measure those concepts and test them for their validity. And then lastly, Joe Bob is a liberal because his mother is one too. Again, much like Senator Stevens, I don't so much care for one individual's political leanings. What does that tell us about the broader world? A better hypothesis would be that people are more likely to adopt the political viewpoints of their parents. We had survey data that measured this. We could test whether this claim is true or not. So always a good idea to make sure that You want to answer the so what question of your research topic. Why do we care? What does this tell us about the broader world? And these are good examples of how to make your hypotheses generalizable. So they're telling us something new about the world, right? That at least applies to more than one specific case. The next major criteria of good hypotheses is that they have to be plausible. And that just means that they have to be rooted in some type of logic, right? There has to be some type of natural, common sense logic underlying what you're saying. So let's take a look at a fantastical hypothesis, which doesn't really make much sense, and then discuss how we could make it plausible. So the first one. People who eat yogurt for breakfast are more likely to be Democrats than people who eat cereal. And as much as I love that, why? What impact? Why does breakfast food type, theoretically on any level, impact your partisanship? It's fantastical. It doesn't make any sense at all. The only thing that I could gather that would make this, within the same vein of question, make it somewhat plausible, is that perhaps what you're really trying to get at is that people who buy organic health foods, they might be more likely to have stronger attitudes on environmental conservation. And generally those things are liberal policy attitudes. So maybe there's a linkage there, right? But the first one, definitely fantastical, doesn't make much sense at all. Let's take a second one. People who live in Georgia are more likely to support the protection of gun rights. And you might be thinking to yourself, well, what's so wrong with that one? And it violates a few things, right? It's the N of one, the sample size of one. Why do we so much care about, how people in one specific state view a very specific policy agenda? A better question might be people who live in the South are more likely to support the protection of gun rights than people who do not live in the South, right? What we're trying to do is just make our hypotheses and our research questions apply to a broad population. So here are some examples of how we might begin with a fantastical hypothesis and actually bring it back to some type of logic, make it plausible. In the case of Georgia, what exactly are you saying about the state? Is the state itself causing, attitudes about gun rights? Or is it something broader? Is it regional, right? Is it cultural, not just the specific geographic boundaries of the state, right? That doesn't really make much sense. All right, my favorite one, specificity. Your hypotheses good hypotheses, testable hypotheses, need to be specific. And really what this means is that we are incorporating an aspect of directionality. So you've probably noticed through most of my examples, I usually say something along the lines of, as X increases, so will Y, or more of this will result in less of that. And that aspect specifically refers to directionality. So here's some more examples of what we mean by directionality. So one thing that this hypothesis is kind of arguing is the conditional nature of, family income and geographical region. So we expect median family income to be higher in urban counties, but lower in rural counties. So there's very clear directionality there. The second one, states with higher poverty have lower voter turnout. So as poverty increases, right, for every value, so say we're looking at state to state to state and we're measuring the percentage of people living in poverty for each state, what we would expect is that as poverty level increases, we would expect that state to also have lower values on voter turnout. And then lastly, students who study more have higher test scores. So here our unit of analysis would be individual students. We would examine the amount of time that they spent studying, and we would expect as hours of time studying increases, we would expect test scores to also increase. So essentially a little bit more nuanced discussion here on directionality is that we can hypothesize positive relationships or negative relationships. So here's some examples of positive relationships. The more education a person has, the higher his or her income will be. So as education increases, that's the independent variable, it has an impact on his or her income. Education increases, so does income. People who read the news are more informed. So independent variable, reading the news. Do you read the news? Yes or no? As news readership increases, you become more politically informed. Informed being the dependent variable. Hypothesis 3. The older a person is, the older a person becomes, the more conservative they eventually become. That's actually a well-documented phenomenon in American politics research. So as people become older, they also become more conservative. There's a positive relationship here. Both variables are increasing. Negative relationships are exactly like they sound. We're expecting something to decrease or decline. So, and this can also have one positive element in it, but the key about identifying a negative relationship is that at least one thing in the statement is decreasing. Okay, so it might be a little tricky at first, but as long as you read the word less or decrease or something like that, as long as that one word is in a statement, it's a negative relationship that you're hypothesizing. Lots more examples of this to come with our homework journals. Here's an example. Older people are less tolerant of protests than younger people. So as people become older, support for social protests declines, right? As income increases, concerns for mass transit decrease. Okay. All right. And the last one, more affluent countries have less violent crime than poor countries. So as a country becomes more affluent, violent crime decreases. Okay. So hopefully that makes sense. Again, positive relationships are really easy to identify in a hypothesis. Both terms are positive. They can actually both be negative and also be positive as well, which might be a little bit confusing. But we will, that will make sense later. I will run through some examples in class. I don't want to belabor the point too much here in this lecture. But be concerned about the directionality of your hypotheses, right? That's where I want you at right now in today's lecture. All right, so the next thing I want to talk about is making sure that our hypotheses are specific, not too broad, but they're just specific enough. So let's start with H1. How a person votes for president depends on the information he or she is exposed to. Well, my God, what do you mean by that? What information? That could mean just about anything. A more specific, appropriate hypothesis would state people exposed to negative campaign advertising are less likely to vote, and there's that directionality, less likely to vote than people exposed to positive campaign ads. Great hypothesis. The second one. A country's geographic location matters for the type of political system it develops. Okay, what type of geographic location? What do you mean by matters? Political system? I mean, this is all just super vague. It's not even broad. It's vague. It's like none of these concepts are clearly defined. Instead, a better hypothesis, countries with more mountainous terrain are more likely to have more insurgency groups. And that's actually a really fascinating area of research, that, you know, when you have all of these mountainous terrains in areas that are not easily accessible, like the government can't come and get you. So that's always a really cool area of research to me. Moving on. A person's capabilities affect his or her political attitudes. Well, what do you mean by capabilities? What do you mean by political attitudes? Again, very broad. Not helpful at all. A better hypothesis, the more intelligent a person, the more likely they are to support civil liberties. All right, great. We've got directionality there, and we've got clear definition of concepts. Lastly, guns do not cause crime. First of all, that's absolutist, and it's not really testable, and it's written in a really terrible way. So what do we mean by crime, right? There's lots of issues with this hypothesis. So instead, what we might say is people who own guns are less likely to be victims of crimes than those who do not own guns, right? That's a testable hypothesis. I mean, again, if we had a survey of people who owned guns and reported whether or not they were victims of crimes, like there's a lot of ifs here, but at least that hypothesis is better than the first one. All right, so those are just some examples of how to turn a broad hypothesis into one that is more specific and testable. All right, fifth, good hypotheses should correspond to the researcher's intention. And this might be a little confusing and not immediately apparent what exactly it means, but this is probably one of the most important criteria for students who are just beginning the research process. And like I mentioned during the first week of class, most people are generally drawn to questions that are longitudinal in nature, meaning that we're interested in observing how some particular phenomenon has evolved over time. Like, why are American voters becoming increasingly polarized? Or why have elections become increasingly competitive? And since the answer to these questions require a really advanced methodology and data collection over years or even decades, I mean, they're just not feasible or appropriate for the scope of what we're doing in this class. So instead, cross-sectional designs, or research that involves the analysis of many objects at a singular point in time, is far more manageable for a course like this. So instead of wanting to analyze how electoral competitiveness has changed over the last 2 decades in the United States, a more appropriate question would analyze this phenomenon at one point in time. So why was the 2020 presidential election closer in some states than others? Finally, I promise finally, this is the last criteria of a good hypothesis. They must be testable. And sometimes we have really interesting ideas, but unfortunately they're just not testable or they're not feasible, at least, for a class like this. So one hypothesis, which is really interesting, right, could be children who are more obedient to authority will be less likely to engage in political dissent as adults. And really, that's interesting, right? But if we think about it, in order to test this hypothesis, we'd have to require it would require a very specific survey to be implemented to a select group of people, and we would probably want to measure these several different factors over time, maybe a period of 20 or 30 years. I mean, lots of surveys do this, but we'd want to interview the parents and, know how they're disciplining their children. We'd want to see how the children react to that, and then how that affects their behavior as adults. So obviously super unmanageable for a course like this. On the other hand, a more testable hypothesis would be that people who raise their children by strict traditional standards are less likely to support political dissent. And all we would really need to do to test this hypothesis would be to find a survey out there that has already asked these questions, or at least has some of these questions on the survey, and then we could compare different variables to one another. Okay. So just keep that in mind. I think at this point I'm familiar enough with everybody's research topic that I think we've solidly put this question to rest, that everyone has a testable research question, but just things to keep in mind moving forward or for research projects you might want to do for other classes. All right, one of the last topics on testability that we need to mention is the problem of tautologies. And you need to avoid tautologies at all costs. They're terrible. A tautology is basically a statement that links two concepts that essentially mean the same thing. It's a nonsense statement. It's not saying anything at all. So an example might be either it will rain tomorrow or it won't. And see, tautologies are worded in a way where they can't be falsifiable. They're always right. So when you say either it'll rain tomorrow or it won't, well, I guess, yeah, either it will or it won't. I can't really test that, can I? Right? The way that it's worded. Here's another one. The senator will lose the election if he doesn't get enough votes. Or can you test that? I mean, like, that's not a testable statement. Like, of course, the senator will lose if they don't get enough votes, of course. Another one. If a country's government is dismantled in civil war, that country will fail. Well, yeah, of course. When a government's dismantled by civil war, that country has failed. So you're saying two things that are super similar at the same time. So you're saying like that one really similar thing is going to cause the same exact thing. It doesn't make any sense. Let's put this into a hypothesis to give you an example of how you might accidentally commit a tautology. So the example is, as support for political institutions decreases, right? So maybe support for like the legislature, the executive, or whatever. As support for political institutions decreases, the weaker the political system will become. Well, yeah, if people don't have faith or support the political institutions of their government, then that obviously doesn't seem like a very powerful, legitimate, strong government, right? This is very problematic logic because institutions are an inherent component of any political system. And in this example, the two concepts are so similar to one another that the statement is always true. It's not falsifiable, right? Sometimes I see students write hypotheses that are tautologies. It doesn't really help. It doesn't really happen very often, but usually a stronger definition of terms and concepts always corrects this issue. But just be aware of what tautologies are and make sure that you don't commit them in your own research paper. All right, everybody, that's the end of the part 2 lecture. When you are ready to proceed with ecological inference, fallacies, and defining concepts, go ahead and click next.